Hey everybody! Again, sorry for the delay on those videos today. I got an email from YouTube actually today explaining that they were inundated by teachers doing exactly the same thing as me, and it throttled the system. So, anyways, this should be uploaded correctly for tomorrow because I'm recording it at night and upload it while I'm sleeping. So it should all be ready to go. The other thing too, if you guys are watching this early, I would like to get a chance to do a Google Meet with everybody in class today. So during your classes, if you want to log in, I'll have all that through Google Classroom on how to communicate there and how to connect. But if you guys want to just see me face to face, we can talk about math or just say hi and you can talk to each other. Don't even have to have me on there. But I would just love to have a chance to get together as a class, and now that I've got my life together, I think we should be able to do that. So anyways, today we're going to be talking about volume. So volume, just in real simple terms, is you could think of it as how much liquid can fit in something. So if you have a 2-liter bottle of soda, for example, the volume of that is 2 liters. So you can think about, all right, you've got some sort of glass. How much liquid fits in there is the volume. Volume is always expressed in cubic units. So, for example, liters, actually, and it sounds like that gallons, liters is all a volume measurement, but it's all based on cubic units. So it's essentially how many little cubes, you can think about how many little cubes of water can I fit in this cylinder, for example. And the cubes in liters are actually cubic centimeters, and we express them like this. A cubic centimeter is the same as 1 milliliter. So 1,000 cubic centimeters is 1 liter. Okay, so 1,000 cubic centimeters equals 1 liter. And that's just kind of the basic idea. But I want you to think about it in terms of cubic units. How many little cubes of stuff can you fit in there? So anything that has a cube unit here is a measure of volume. And usually when we're talking about volume in class, you'll see units like, might give you a prism like we had in our surface area thing yesterday. And I'd say, okay, if the one from yesterday had 10, 2, and 4, we might say that this is feet. Okay, so we could talk about cubic feet in this case. Maybe it's inches would be cubic inches. So you don't have to worry necessarily about conversions like this down here, but I just wanted to give you an idea, since usually when we talk about volume, we talk about liters. Liters are actually directly related to cubic centimeters. Gallons, the same thing, except that those are based on ounces. So again, it's always an idea of like how many cubes of stuff fit in something. Volume is way easier than surface area, so you guys will be happy to know that. With surface area, you have to get creative and you have to find all these things. You're like, okay, how do I find the area of this space versus this space, and adding all that stuff up? It can get annoying. Volume is really straightforward. Every equation except for one is essentially this. All volume is equal to a simple equation here. Let me just adjust this real quick. Volume is simply the area of the base times the height. So it's one more dimension. So instead of regular area we find by doing base times height, volume is the area of the base times the height. So if we wanted to find the volume of this prism up here, I would need to find the area of the base. And the base in this particular case is this rectangle down here. So the area of that base, that's just a rectangle with a length of 4 and 2. So the area of that would be 8 square feet. times the height 8 times 10 is 80. So it's 80 cubic feet. And that's it. Like, it's easy. Area, volume is just super, super easy, particularly if you've really been doing the stuff that I'm talking about in area, where we don't necessarily memorize formulas, but we think about what's going on, where we find the area of different faces and adding them up. If you're good at finding the area of stuff, volume's going to be easy, because you find the area of one thing and you multiply by the height, and that's it. All right, so it's pretty cool because it's simple. The only challenge at times is going to be to find which side the base is. Okay, so I'll give you an example here on why it could be challenging. So let's look at a shape like this. All right, so here is my shape. And I'll go ahead and draw in the dashed lines here so you can see behind. But that's your shape. Does anybody know what this one is called? This one is called, if you can name it, this is not a pyramid, so be really careful with this. This is a triangular prism. Remember, anything that's a prism is something that has rectangle sides. Okay, so prism equals rectangular side. So this is not a pyramid, even though it has a triangle on it, because it has rectangle sides. So the trick is, which one is the base? And that's the tough one in this triangular prism, because our temptation is to say that this side down here is the base. That is not the base. That's one of the sides, because this is a rectangular, or this is a triangular prism. The prisms, the sides are always going to be rectangles. The base is from the name. Okay, so the base is from the name. So the base says triangular prism, so that means that the base is a rectangle. So the base is actually one of these sides right here. And we need to then figure out what the area of that base is and multiply it by the height, which is 20. So what I want you to get in the habit of doing is, if it's helpful, actually turn your paper. Say, oh, I can see the base now. It's this side. And don't be afraid to do that on your test. So if you got a test, because there will be a test on this coming up next week, so be prepared for it. Don't be afraid to move it around. Draw a picture and change it up. Okay, so the base here, and again, what I'm going to do is I'm just going to draw the base separately here, is a 3, 4, 5 triangle, and I'm hoping that that looks familiar to you. We have done 3, 4, 5 triangles repeatedly and continuously. The question is, what's the height? Because I didn't give you any right angles. So is there a right angle in here, or is the 4 the right angle? And how can we tell? I'd love to be able to ask questions and have people raise their hands right now, but I can't, so hopefully you're just shouting it out or pausing and thinking about it. But the truth is, this is a right triangle already. This is my right angle right here. The way that we know that is that we can use the Pythagorean theorem to check it. Pythagorean theorem is only true for right triangles. So that means if this is a right triangle, that means that 3 squared plus 4 squared must equal 5 squared. If that's not true, it's not a right triangle and we need to do some more work and find the height. But we can check it here. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And it turns out that 9 plus 16 does equal 25. Since that's exactly true, that means this has to be a right triangle and I don't have to do any extra work. So I do base times height. 4 times 3 is 12. Divide by 2 to find the area. The area of the base is 6. And I didn't give you units again because I'm a terrible teacher. So let's say these are inches. So this is going to be 6 square inches for the base. And we're going to multiply times 20 inches. So 6 times 20 is going to give you 120 now cubic inches. And that's it. That's volume. Again, the only difficult part of volume can it be at times to find which one is the base. And I want you to be looking for that, and don't be fooled. The one that's down does not necessarily make it the base. So be careful there. All right, so let's try a couple other weird ones, and then I'm going to set you loose on some homework. And we can, if you have any questions, you feel free to email, or we can talk on live stream. Again, my plan is to do a Google Meet, so I'll give you guys the link there to ask your questions. So let's look at some weirder shapes. How about a cylinder? Let's make this a little taller. So maybe this is your soda can, or whatever. Maybe it's your can of LaCroix if you're like my wife and you just drink that stuff. Actually, I love that stuff too. That stuff's amazing. Particularly the LaCroix in the fancy bottles, the skinny ones. I have one over here. I'm just going to grab it. Yes. And if I were an influencer, this would be my product placement for today. Choose LaCroix. It's the best sparkling water. Yeah, and I got it for 10 cents at King Soopers. Shop at King Soopers. But wear a mask because it's gross right now. Anyway. Let's do some math because I'm all over the place. It's too late for me to be recording video right now. Some of you guys are like, Mr. Calbeck, you're always like this, and you're not wrong. So let's say that this is 12 centimeters tall and has a radius of 4 centimeters. We want to find the volume of this. That's how much LaCroix fits in this can. Again, how many cubic centimeters would be what I'm looking for here because it's all in centimeters. So I want to find the area of the base, and the base in this case is the circle. So we find the area of the circle. Remember, it's pi r squared is the area, so pi times the radius squared, or 4 times 4 is 16. Generally, when we write these, we put the number first. We say 16 pi. And that would be square centimeters, because we're talking about area right now. And then we multiply that times the height, which is 12. Again, area of the base times the height. 12 times 16 is 192, and I can tack the pi on there, and that would be cubic centimeters. The other thing you can choose to do, if you want, is to use the pi and put that in there as well. If you do that, that is 603.2 cubic centimeters if you decide to use pi as a number. Again, use your calculator to do that. Use the pi button. Round only at the very end. 1 or 2 decimal places is fine. All right. There are a couple of stranger examples here. Let's go ahead and turn that around so we can have a little bit more room. For example, pyramids and cones are weird. Remember, you draw kind of a flattened circle, connect the sides to make a cone. Draw a flattened square or any other shape if you want to do a different kind of pyramid. Draw a dot above it and connect all the vertices to make a pyramid. Okay, and these are actually the same equation. Just like with a triangle is, when I find the area of a triangle, remember, it's half of the regular area, because a triangle, every triangle, no matter what kind of triangle it is always going to be half of a parallelogram, and a parallelogram is base times height. Okay, so I take the whole area and it's like, I don't want that one. I just want half of it. Okay, now the question is, with a thing like a cone, it looks like it could be sort of based on a cylinder like we just did. The question is, how much of the cylinder is it? Now, if we had an opportunity to actually be in class, I have some cool plastic see-through ones, and we could actually measure how many cones would fit into the same size cylinder. Since I can't do that, I'm just gonna tell you, it's 1/3 of the volume of the cylinder. So this one is the area of the base times the height, and we just do it times 1/3 in this case, because it's 1/3 of the volume of the cylinder. The pyramid, same question. The only question is, this one would be a square prism that it would be made up of. And the question is, how much of the square prism does the pyramid take up? And the truth is, it's actually 1/3 as well. So both of them are 1/3 of the total volume of the shape they fit inside. This fits inside a cylinder, and it's 1/3 of that volume. This fits inside a prism, it's 1/3 the prism. It doesn't matter what the base looks like, whether it's a circle, a square, a triangle, an octagon. If it's a pyramid or a cone, it's 1/3 of the volume. So let's do a practice problem here, and let me show you what that looks like. Okay, and again, with cones, sometimes they're going to be a little tricky about finding things. So let's do this right here. I'm going to tell you the radius. The radius is 10 inches. And I'm going to tell you the slant height. Remember from last time, the slant height is that diagonal distance. The slant height is, let's do 14. All right, so the question is, what is the height of this pyramid, or of this cone? Okay, I didn't give you the height. I can still find the area of the base though, which is, again, pi r squared. The radius is 10, so that's pi times 10 squared. 10 times 10 is 100, so this would be 100 pi. That's the base. Again, that's 314 if you want to type it out. I just like to leave the pi in because then I don't need to use my calculator and mess something up. The question is, what's the height? That is the big question. And remember, if you don't know something, get creative. Don't be afraid to try something, draw in some extra lines. We need to find the height. And as it turns out, this is a right triangle, and I can use the Pythagorean theorem to find the height. Because it's going to be 10 squared plus h squared equals 14 squared. And so you have 100 plus h squared equals 196. Subtract, you get h squared equals 96. And if you take the square root of 96, it's going to be a little bit less than 10. So h is going to be equal to, call it 9.8 inches. So if I want to find the volume of this, I do 100 pi, and I'll go ahead and type that up for you if you didn't do it in your own calculator. So that's 100 pi is 314.16 approximately times 9.8, and that's going to give you the volume of the, not the cone, it's actually going to give you the volume of the cylinder that the cone fits inside. Because remember, it's area of the base times the height. Okay, so that is going to be 3,078.8 cubic inches. But that's not the answer, because remember, it's 1/3 that volume. So I times that by 1/3. In your calculators, when you're doing 1/3, so if you have 3078.8, and you want to multiply by 1/3, go ahead and put it in parentheses and do 1 divided by 3. And that will give you the right answer. Do not, and I repeat, do not put 0.3 as an estimate for 1/3. It will give you the wrong answer, and I will not count it. Take a look at how different these are. Oops. So if I type in 0.3 here instead of 1/3, look at how different the answer is. I'm off by over 100 by not multiplying by 1/3. Okay, so when you're typing in your calculator, 0.3 is not equal to 1/3. It's 0.3 repeating for all infinity, and your calculator doesn't have that many decimal places. So instead, do in parentheses 1/3. Okay, so the correct answer is 1026.3 cubic inches. All right. Again, with a pyramid or a cone, it's the same thing. Okay, and you're going to be finding 1/3 of that volume. So that's it, actually. We don't need any more video for today. I'm going to go ahead and give you your homework assignment. It's going to be out of big ideas. So go ahead and try those on your own. If you have questions, go ahead and ask me. I'll be around tomorrow. I miss seeing you guys. I hope your lives are great. I hope you missed my absolutely terrible product placement that I'm not getting paid for. I hope you missed my terrible dad jokes, and because I miss you guys too. It's been really difficult actually trying to teach from home. And I'm really sad about just not getting to have you guys whine about having late homework to my face. Just kidding. I miss seeing you guys after school. I miss hanging out with you. I miss hearing about your lives. So please tell me about how things are going, and if you do need anything, let me know. This is Calbeck signing off.